Hello friends, here in this video we will see a problem on pentagonal prism. Here's the question. It is given that a horizontal pentagonal prism, side of base 32 mm and axis 70 mm long, has its rectangular face on HP. Its axis is parallel to HP and perpendicular to VP. A cutting plane perpendicular to HP but inclined at 45 degree to VP cuts its axis at a point 20 mm from the center of base. Draw its sectional front view, top view, sectional side view and true shape of the section. So this is the question in front of us. First, by reading it, we understood that the type of solid is a pentagonal prism and there are various conditions given in the problem. Those conditions I'll be explaining step by step. First, I'll draw the pentagonal prism and explain the given condition. Let us get started. So here is the diagram of a pentagonal prism and it is having two pentagonal faces. These are the edges which are connecting the two pentagon. Edges of the pentagon. This is the pentagonal face. Here we have a pentagonal face, another pentagonal face is on the other side. Then here there are 5 corners of this pentagon connected with the other 5 corners of the pentagon onto the other side with the help of straight edges, and these edges are forming rectangular faces. So it means here when we have a pentagonal prism, then in that case we are going to have 5 rectangular faces. So these are the rectangular faces. Now in the question it is given that a horizontal pentagonal prism, side of base 32 mm and axis 70 mm long, has its rectangular face on HP. So it is kept in this way which I have drawn here. Means the pentagon should rest on the ground. Ground is also called as HP. So here the pentagonal prism is kept on the ground. Now the pentagonal prism is kept on one of its. It is given that horizontal pentagonal prism, side of base 32 mm and here I have kept it horizontal, and axis 70 mm long, that is the length, has its rectangular face on HP. So it is resting on the rectangular face on HP. HP means that is the ground. So here the pentagonal prism is resting in this way which I have shown here. So in that case the axis is parallel to HP, that is axis will be parallel to the ground. So the axis will be parallel to the ground and perpendicular to VP. It means when the pentagonal prism is kept in this way and we are looking at this direction, that is the direction of arrow X. From here we are going to see the front view, and in the front view we are going to see this pentagonal face. Next, in the top view we are going to see the rectangular faces, and when we are projecting the front view onto VP, because front view will be seen in VP as per first angle method of projection, then this axis will become perpendicular to VP and it will appear as a point, whereas in the top view it will appear as a line. So let us get started by drawing the initial condition. This pentagonal face will be visible in VP, so starting with that, and it is having side of base as 32 mm. At first, drawing a light horizontal line. Here we have XY line VPHP. Now, as I have explained, the pentagonal face will be visible in VP and it is having 32 mm side. Measuring 32 mm. Now in this problem, as we have to draw the side view and also we have to draw the true shape of the section. So starting the front view from here, then the edges of the pentagon are inclined at 72 degree. Here I will measure the side of this pentagon, which is 32 mm. Drawing a light arc, cutting it from the other side. Since it is a pentagonal prism, here we are not going to connect the corners because it is not a pyramid, here it is a prism. Then giving it the notations. So this is the front view of that pentagonal prism, which is resting in HP on its triangular face. Now I'll have to project its top view. Here the axis height is given as 70 mm. So 32 mm is the side of the base and axis 70 mm. So the length of the pentagonal prism will be 70. On this center line, I'll mark the distance of 70 mm. So this is the top view of that pentagonal prism. Now I'll give the notations here. Since there is one pentagon on one side, pentagonal face, and there is on the other side also there is a pentagonal face, so I'll give the notations on both the sides. That is point 1 here, point 2, this is 5, 3 and 4. Similarly here. Next, here I won't be making this dark because we require the cutting plane. Once we have located the cutting plane, we can make it dark, and for that the condition is, now it is given that a cutting plane perpendicular to HP but inclined at 45 degree to VP. Now inclination with VP is given. That inclination is called as phi, and it will be seen in HP. Now where the cutting plane is cutting, cuts its axis at a point 20 mm from the center of base. So here we have the base, and from the center of that base it is cutting at 20 mm. So here, and the observer, since this is the top view, observer is located here. So taking 20 mm, so now here I'll measure 20 mm from the center of the base as mentioned in the question, drawing a light line through it and measuring an angle which is given 45 degree to VP. So I'll measure the angle from here. Inclination to VP will be seen in HP. And since here when we are plotting it, when we are looking as an observer in this direction, then here we have a pentagonal face, this is another pentagonal face, so we have to measure the distance from the base, and that distance from the will be from the other side because it is going behind the observer, and we want the distance of 20 mm. It is given that the distance is 20 mm from the center of the base. So here as I have plotted, and the angle is 45 degrees, so yes, this is correct. So this line indicates the cutting plane, and after I have drawn the cutting plane, I have to cut this prism and retain some part and remove some part. So that part which is closer to the observer has to be removed, remaining has to be retained, so that we can draw the sectional front view. So here I'll make this cutting plane dark. When we are looking from top, this point 5 is visible because as an observer, when we are drawing the top view, this point 5 dash is visible, so this edge will be dark. But 2 and 3, they are going behind the observer, so that edges will be hidden. And this edge will be dark 1 to 1. Next, here I locate the direction of the cutting plane, calling this as cutting plane A dash. Now here, if we look at this diagram where the cutting plane is cutting this prism, here we have edge 1 2, so it is cutting this edge 1 to 2 at a location, I'll say that is point A. It is cutting edge 2 2 at this location, I'll say that is point B. 5 5 is cut at this location, that is C. 3 3 at this location, so that is D. At last there is 4, so point E. Now projecting these points upwards, so this point A will lie on this edge 1 to 2. So here is point A dash. Then point B and 2, they are onto the same line, so where we have 2 dash at the same location, there will be the point B dash. Next, C will be at the same location as 5, so this point is C dash. Then D will be at the same location as 3, so that will be D dash. And E will be at the same location as 4, so that will be E dash. Joining them with the help of light line first, so A to C will be connected. Remaining all points are there, so I'll make it dark. Then when we are looking as an observer here, at that time this from 5 to 1 will be visible, and 1 to A, that is also visible, so I'll have to make it dark. Then I'll draw the section lines over it. Measuring 45-degree angle. So this is the sectional front view. It means when the pentagonal prism is cut in this way, then here we are going to get the sectional front view. Next, I'll plot the sectional side view, and for that we would be looking from right hand side and projecting it on left hand side, because here is where we are going to see the sectional side view. And for that, measuring here, taking a point, measuring an angle of 45 degree, drawing a light line through it, projecting the length, which is 70 mm length, or we can say actually that is the height. Now so here is that pentagonal prism in the side view. We would be looking on right hand side, drawing it on left hand side, so that is the right hand side view by first angle method of projection. Now here in this case, I'll be getting the points in the side view. Now I'll mark the points here, 5 dash, and here we are having 5 on this line, so where they intersect, that will give me the point 5 double dash in the side view. Similarly 5 is also there at the bottom close to the observer, so point 5 double dash. Then 1 and 4 are at the same location, 1 and 4 is here, so I'll plot them as 1 double dash comma 4 double dash. Similarly here 1 double dash 4 double dash. Then 2 and 3 are on xy line, and again 2 and 3 are passing through this line from the top view, so it is 2 double dash 3 double dash 2 double dash 3 double dash. Now this is the side view of the pentagonal prism. I have kept it light because we have to show the sectioning over that. We cannot make it dark directly, so for that I am going to project the points. Like point A is on this line, which is 1 to 2, and here also I am getting point A. So for that I will be projecting a light line of point A. Then point A all is on this edge, which is close to the observer, as we see here. Here we have 1 dash 2 dash in the front view, over that we have point A dash. Similarly in the top view, that is 1 to 2, 1 to 2 is there on both the sides, so we have to take the edge which is closer to the observer. So this edge will be here, which is closer to the observer, so this will be point A double dash for us. Here we have A double dash. Then point B dash is here, it is on this same line as 2 to 3, so B dash will be projected. Projecting it light. Then here B dash is on xy line, so this point B should reach up to xy line. Where they intersect, that will give me the point B double dash. Then point C is there at the top, and here I am having point C at this location. Projecting it light. Where this intersects this line, 5 dash 5 double dash, here I'll get the point C double dash. Then point D is again on xy line, here D dash, and D I'll project it. So here we have point D, and this will be D double dash. Then point E is on this location, and here we have point E in the top view. So from the top view I'll project it into the front view. Here it gives me the point E double dash. Now joining them in proper sequence with the help of light lines. A double dash, B double dash, then B to D, D to E, E to C, C to A. Next, here if we see, then here the portion which is from A to 5, that is A double dash, 2 double dash, 5 double dash, 3 double dash, and 4 double dash, and that will go up to point E. So it means when we are projecting it, in that case, I'll make it dark first. So this much portion is visible. Next, when we are looking as an observer onto the right hand side, the edge or point 1 dash is going away from the observer, and then again I can say that the one double dash which is close to the observer, that is visible. Next, 5C, 5 dash, 5 dash and C, at the same time 4 dash and E, they are connected. Then from 5 to A dash, it is a dark line. So 5 double dash to A double dash should be a dark line. Similarly, A to 2 and then 3, they are connected. So here I'll connect them in order. This much portion is visible. 5 to C is visible. Up to B it is visible, and this portion which is there on the right hand side, that has been removed. So only this much part of the prism is remaining. So I'll draw the sectioning lines over it. So this is the cut prism. Next, when we are looking from this side, this edge E to 4, that is visible, or we can say that when we are looking from this side, then here this much portion will be visible. Next, I'll give the dimensions to it. Edge of base was given as 32 and axis height was 70 mm. Axis height 70. Next, inclination of the cutting plane. It was inclined at 45 degree to VP and at a distance of 20 mm from the base. Next, for the true shape of the section, I will have to make this cutting plane parallel. Measure the length of the cutting plane from A to E. Then from A to D, A to C, and A to B. Projecting the points upwards one by one. So point A, when projected up, A and A dash where they intersect, that will give me A double dash. Point B is on XY line, so point B where it intersects, that will give me B double dash. Point C, this will be C double dash. Then point D is on XY line, D double dash. At last point E, so that is A double dash, E double dash. Joining them in the proper sequence will give me the true shape of the section. Making the cutting plane dark. Cutting plane A dash, then drawing section lines over it. So this is the true shape of the section. And with this we complete the problem.